in a hot second.
Ah, there we go. I see it.
Okay.
Okay.
It still says setting up, so let y'all know when it's actually live and somebody can check and make sure it's all good.
Okay.
Fabulous.
Okay, let me just make sure this is working on YouTube, and we'll get started very shortly. Oh yeah, it's on YouTube. Okay, that's perfect. All right, I'm gonna pause the music. Hold up. All right, can you guys confirm in the chat that you can no longer hear the music? Okay, that's awesome. All right, so hi guys, welcome to our first Spotlight presentation and our first event of the Pulse Conference. Here to kick it off, we have Danny Gardner, the CEO of Mesh++. And so Danny is a alum from U of I who graduated in 2017 with I believe, a bachelor's in electrical engineering. And he actually took his capstone project as a senior, which was a distributed mesh network system that he actually built on the Granger Quad. And I believe he hosted a version of Wikipedia on that, but he'll get more into that. And he was able to take that idea or concept of mesh networks and scale it into the company that he owns today, or is the CEO of today, Mesh++. And I believe current applications or things that Danny has done with Mesh++ involve using them for outdoor concerts and parks, as well as I believe in the city of Chicago, he's made a profound impact as well. And so without further ado, I'm going to stop sharing my screen and I'll hand it over to Danny himself.
Great, thank you very much, and thanks so much for having me. Let's see, can you see my screen now?
Yes, we can see it just fine.
Okay, great. So I am Danny Gardner. I am best known to co-author the Senior Design Sample Design documents. I just checked that they're still up, and I'm pretty proud of that. It's, I think, a good showcase of growth, certainly seeing where I was 5 years ago and being able to see how the idea, my own engineering skills have evolved over the last 5 years. So I started out as a hobbyist. I would get in trouble in high school and late middle school for building high voltage devices and lasers, and kind of settled into wireless communications. I'm sure a lot of you are very interested in wireless communications. It's interesting both because of course, the physics behind it, but also the impact that you can eventually have. I am not really coming from a networking place. I've more built little wireless radios as really a hobbyist. And something that I'll note is a lot of people who are in my place, especially coming from engineering school, were entrepreneurs and wanted to start a business. And I am probably the exception where I never planned to start a business. And I'll talk a little bit more about my story and how I got here. But it did not start from a place where I wanted to own a company, et cetera. I kind of got dragged kicking and screaming into actually launching a business, thanks to the U of I ecosystem. So thank you for that. Well, at UIUC, I majored in electrical engineering. I got minors in physics and T&M, which is business. I think the most important thing that I can say about my time at U of I is that about my sophomore year, I figured out how to teach myself. That is certainly a valuable skill right now where everyone's learning remotely. And really being forced to teach yourself in some respects. But really, when I figured out how I learned best, which was about my sophomore year, my GPA shot up and I was able to take on so much more because if you are trying to force yourself to learn in a way that's not the most efficient for you, you end up wasting a lot of time and it's not very effective. When you come out of college, of course, you'll be teaching yourself most of the information. So one of my pieces of advice is to figure out how you learn best, whether it's audio or visual or doing homework or even studying for tests or watching YouTube videos or something, and then just leaning completely into that. It'll make for a much more efficient use of your time. Fortunately, U of I is such a large school with so many different resources that whatever the way that you can learn is, there are resources for you. And I'm very, very thankful that there were for me during undergrad. The project started out in ECE 445 in senior design. It actually started out a semester earlier in ECE 398 PSC, Paul Scott Carney, who's now at Rochester. The idea was to take some of our engineering knowledge and put it into a product that could really help people and be financially sustainable at the end of the day. Of course, it's very important to take the skills that we learn at school and make it into something that contributes to society. And that's a big part of what I think senior design is about, and associated other innovation courses. So I found some of our early prototypes. I don't know if you can see my camera still or only my screen, but this was my original senior design prototype. And you were right, it hosted Wikipedia on the school squad. It was, there's a couple different microcontrollers on here and then some flash, and it could store images and HTML web pages and be solar powered. So our idea with this product was to say that in order to bring internet to underserved areas, we need to completely detach ourselves from any sort of existing infrastructure. There are a lot of areas around the world that don't have reliable power, a lot of areas that don't have the ability to lay cable, for example, whether it's financial or other. And so if you can build a product that is able to connect people without relying on infrastructure on the ground, you can dramatically lower costs and expand into areas that just weren't possible before. It's the same sort of concept behind a lot of major companies tackling this, like Starlink, for example, who are an infrastructure-free solution. And so we were trying to do the same thing on the ground level. This could support maybe 1 or 2 people at the same time. We quickly realized that some of the low power solutions for connectivity were not really broadband solutions. It was helpful for hosting web pages, but it wasn't useful for very much behind that. So after senior design, so I went through senior design with my friend Jeef, who is now at IBM. And after the course had ended, we did fairly well, and we knew that we could help people. We had to write a business plan as part of it, which is the first business plan I ever wrote. Well, a 2-page business summary at the beginning of our documents, I guess. We realized that this could make an impact, and we could potentially sell this in areas, but most importantly, help people. So we applied for the iVenture Accelerator, which was very valuable to us because both of us, being engineers, we didn't really know how to take this plan that we had written, this idea, into something that could be a financially sustainable business, which is necessary for any long-term project. But more than anything, we just wanted to keep working on it. We liked the idea. We liked tinkering around with electronics. We were kind of knee-deep into the project. I would say we weren't happy with the prototypes that we finished at the end of senior design because there's always room for improvement. And we wanted to keep working on it, but of course, it's hard to fit it into your busy schedules with all the courses that you're taking. So we applied to the iVenture Accelerator, mostly because we knew that if we were part of it, we would be able to get course credit for the project that we were working on the following semester. If you aren't familiar with iVenture, they give you, I think it's, I'm not sure if it's still, but it was at our time, they would give you $10,000 to work on a business idea of that you submit, and they would pay the people attending for an internship. That was kind of a perfect ground for us to learn all these different things that we didn't know. The following couple semesters, then we took seminars in the College of Business to learn how to build a sustainable business around this. So I'm forever thankful to both Senior Design and the iVenture Accelerator. Right before I graduated, the kind of position that I was in, I had mentioned before that I'm not an entrepreneur. And at graduation, I had an internship lined up at Apple, and I was about to start at Stanford for my master's. And this was important because it was kind of an unreachable idea for my whole life, that I would be able to work at such an incredible company and go to two really incredible engineering schools. So it was, when I say that I was kind of pulled kicking and screaming into starting a company, I mean it. I was very excited to do research, continue doing wireless communications in academia and as a hobby. But what happened was, as part of one of the courses that iVenture had us get into, we took part in the COZAD New Business Venture Competition. So that's a competition that occurs every year in the late spring, where you present a business plan and you build a team, and it's judged by a lot of esteemed entrepreneurs associated with the U of I ecosystem in the area. We ended up getting second place at COZAD through this course by partnering with a number of people in the College of Business and in engineering who are able to fill in a lot of the gaps that we had when we started the company, especially around business. After COZAD, we got, as part of second place at COZAD, we got an investment from Illinois Ventures, U of I's Evergreen Venture arm, and realized that we could really make something of this. We got additional funding, again, thanks to U of I's ecosystem. Illinois Ventures had applied us to get into HAX, which is a hardware accelerator. It's the largest in the world. It's based out of Shenzhen in China. An accelerator is similar to iVenture, but kind of scaled up. It runs you through the steps in starting a business, helps connect you with people, things like that. It's kind of a fast track, like a hackathon that lasts a few months, for example. There have been a couple other successful companies that went through the HAX hardware accelerator, including Petronics, who is now Sprite Robotics, Amber Agriculture, just to name a couple. Amber Agriculture, who is, by the way, right down the hallway from us right now here in Chicago. We've kind of created a little cohort of U of I companies up here in River West. So Illinois Ventures had applied to us to get into the accelerator. We ended up getting in, which completely surprised me because I was at that point ready to give up on the project, really. But at that point, it became more and more clear that we could make something of this. So I quit my internship. I dropped out of grad school. And I, of course, as all roads lead, I came back to U of I. I worked out of Enterprise Works. I worked for Professor Singer's startup, OceanCom, based out of Enterprise Works at the time. Now they're in Chicago. They did underwater acoustic communication. I would work there during the day, and then at night, I would go next door to an office in Enterprise Works that we had won through COZAD, and I would work on Mesh++. We spent that summer preparing for going to the hardware accelerator and preparing for living in China for 4 months. To give you an idea of what our electronics looked like when I graduated, it had shrunk a little bit and looked a lot more professional, although still had a great number of problems. When we went to HAX, we had 3 people total. Like I said, that was kind of a hackathon for 3 months, but Shenzhen is kind of an amazing place. It's like a big candy shop of electronics where you can find any sort of component you want just by kind of going downstairs and going to the market. Most of the electronic products that you'll find are located there. I don't think it would have been possible to go through the rapid prototyping that we went through anywhere else in the world, certainly. After Shenzhen, like any good tech startup, we moved to San Francisco. We started meeting with investors, started looking for real investment. That's the point in time where we started to really develop our IP and what made us so special. We aren't the only company to come up with solar-powered mesh networks, of course, but we had over time started to optimize them a little bit more. We started to realize that a lot of the mesh networking topologies that exist in the world today and are used in homes or offices were not really fine-tuned for large area coverage outdoors, where you're trying to cover tens or hundreds of acres, both because of there's a challenge in area coverage and user density, but there's also kind of a break in how reactive and flexible your network needs to be. You don't need to manage multipath interference, for example. You can assume that you have relatively symmetric links between the points, or at least for the sake of creating an algorithm, you can. So at that point, we developed a system of essentially a routing protocol that's able to locally synchronize packet transfers within a mesh network, reducing loss per hop, the throughput decay from each point, to around 15 to 17% in a very idealized network. It doesn't work very well inside of a home or an office, for example. It's certainly not an all-purpose network, and it needs relatively rigid spacing. You need somewhat equidistant spacing and kind of an isometric grid over areas. But when it was set up in such a way, it operated very effectively. After San Francisco, we drove across the country back to Chicago. We are based out of MHub, which is a hardware incubator. It allowed for very rapid prototyping. All throughout the course of the company, we have continued to not use a contract manufacturer. Most companies in our position would hire a company to build the product that you've designed and source all of the components. And for better or for worse, we never did, which meant that we were doing a lot more prototyping in-house. And we are also doing manufacturing in-house for the most part, or at least with a network of 30 or 40 different factories that source our individual components. About a year and a half ago, no, 2 years ago now, we moved into a real office in Chicago, which is where I am now. A little bit larger space, being a hardware startup, it helps to be able to spread out a little bit. Certainly all the double E's in the audience can imagine that. And most importantly, we started to accomplish the original mission. When we started the company, we wanted to connect people who didn't have any other options. We wanted to provide a type of connectivity that could go to new places. It was not necessarily higher performance than anything else out there, but it was something that was affordable and that was flexible and that gave the power to set up and maintain networks to communities themselves. We really, I'm not happy with our ability to have accomplished that over the first few years. Part of it was the fact that we were venture funded, which poses restrictions on where you can go. Part of it was that the tech wasn't really ready. The hardware took us a few years to get to the point where we had a lot of stability. To give you another snapshot, about 3 years ago, or 2.5 years ago, we made the big shift from little embedded HTML hosting devices to actual networking devices. This one is a quad-core A7, I believe, that we designed around. So there's a lot more power. You can support a lot more people, and you can start to use it for actual broadband access. We started selling our products for underserved communities and emerging markets about 1.5 years ago now. So not for a terribly long time. We spent a long time setting up networks for testing in temporary events, like we were at the Super Bowl, we were at the Special Olympics, we were at the Oscars, for example, setting up temporary networks. But we reached stability in our firmware and hardware about a year and a half ago to start actually selling our products. We didn't get very far until COVID came. Internet connectivity, of course, has been incredibly important for during the age of COVID. It's of course the reason why Pulse is able to exist and why everyone can still go to school. But a lot of people around the world don't have that. And what continually surprises me is that a lot of people who it seems like they're in cities, they're in urban areas, they might have fiber right outdoors. They don't have that either. There's a lot of kind of complicated legislation on where fiber needs to go that has some flaws in that it doesn't actually make it both available and affordable for everyone. So when COVID hit, we decided that we needed to help like a lot of other companies. We partnered with Verizon to deliver the bandwidth. We put a cellular modem in each one of our devices, and we started to set up our nodes around different cities in the US, working directly with the mayors or the CIOs of those cities. So we have networks in 4 or 5 parks here in Chicago, networks in Columbia, South Carolina, Miami, New Orleans, Cleveland now, all over neighborhoods that would normally be underserved, or even have, this blows my mind still that there's fiber right outdoors, but people just can't afford it. So I'm very fortunate that we were able to both work with a company like Verizon, an incumbent, and be able to streamline progress with cities themselves and move really, really fast. Part of the reason why companies have seen so much growth during COVID is that the red tape was kind of cut, especially in the beginning, so that you could move really fast in order to help people. And for the first time, I believe that we did really help people the last spring. I'm proud of that, and it's really started a trend. At this point in time, our largest network is in the Democratic Republic of Congo, over a city that is right next to a volcano and doesn't have any actual wired communication throughout the city because there's a volcano there. Natural disasters would break down the cabling, so it wasn't worth the investment. At this point, where we've got about a dozen people, 9 people full-time, actually maybe 15 part-time. I should know exactly how many people we have. Sorry for that. We're hiring embedded engineers and mechanical engineers, if anybody is watching. Both of those being close to the hardware, those would be based out of our office in Chicago, partially remote until COVID is over. Although I will say that telecommunications is considered an essential business. So we are actually able to get the COVID vaccine. So if you're ever up here in Chicago and you're a good embedded engineer, mechanical engineer, and really enjoy working on technology like this, shameless plug to shoot me an email, danny@meshplus.com. So that brings me to advice. First one is to accept failure and prepare yourself to failure. I think it's easy to get into a mindset where you try to prevent yourself from bad things happening, and you're never going to be able to make progress that way. You have to be prepared to fail, especially as engineers. I mean, scientists will conduct the perfect experiment and invest in equipment. Engineers will assume that something's going to fail and just make sure that it fails in a graceful way. If it does, you don't have bad failure modes, or you'll just totally overbuild the system so that you have a pretty comfortable safety margin. Things go wrong. In fact, I have an example of this just over the last few days. There has been about almost a foot of snowfall around Chicago over the last couple days. It happened pretty fast, and for the first couple days of snowfall, I have been riding my electric scooter around in the snow, which sounds bad. I know it seems you probably shouldn't be riding a scooter in a foot of snow, but the thing is, when a scooter gets stuck, you can just kind of bring it out of the snow, and you can just kind of pull it out. It doesn't weigh very much. I noticed that while I was riding my scooter, it wasn't the safest thing in the world. I did fall off a couple of times, but there'd be a lot of cars that were stranded. And of course, that wouldn't happen to me because I can just pick up my scooter. This morning, the outlet that was charging my scooter had it was a GFCI outlet, and it had the outlet was tripped because of melted snow coming into our garage. So I couldn't ride my scooter. So I borrowed my roommate's car and immediately got stuck. Everyone, when snow comes out, seems to gravitate towards four-wheel drive cars, things that are larger so that you can go up and over the snow. But I had to enlist the help of all of my roommates to come push this car out of the snow because I used something that most people would consider safer or more applicable than my scooter. That's actually the reason why this deck is not super polished, is because I was pushing a car out of the snow. Tying that back into accepting failure, if I could choose to drive a car or to use a scooter, even with a foot of snow, I'll ride my scooter every day, because when something bad happens, and something absolutely will happen, I'm able to pick it right up and continue on. And that's really the story of Mesh++ as well. We fail 10 times more than we're successful, but you don't really build on failures except for your learnings because of them, and your learnings to do things better in the future. But you can build on successes. Therefore, it's almost always worth taking a risk in most situations, especially at the point in your life where you're just starting out your career. You can gain a lot more experience by taking risks than you can if you just assume that you're never going to fail and take the easy path. Next, and I mentioned this before, is learning how to teach yourself information. It's invaluable in the real world after you get out of college, but I think it's also invaluable during school, especially during COVID, of course. It really changed my life and my academic career when I learned how to teach myself best. My answer to that question, by the way, was in doing. I don't learn very well in classrooms. I learn really well by just going out and doing something. So I was able to save a lot of time that way. But of course, everyone's different. People learn in lots of different ways. Just figure that out sooner rather than later. It'll also help you communicate with people. I, for example, learn best through diagrams, not through walls of text. But I've worked with a lot of people who learn best through walls of text. I'm able to communicate with them effectively because I understand how I learn best, and I understand how they learn best. Next, the most valuable skill is knowing your own skills. Nobody is good at everything. Everyone has flaws, and much more damaging than having skills that you don't much more valuable than not having a certain skill set is thinking that you have a skill set but not having the skill set, or thinking that you don't have a skill set but actually having that skill set. It means that that kind of nugget of things that you're good at is not going to be effectively utilized, and you're not going to be a very effective engineer at the end of the day. I think the biggest challenge that I've seen people have over the course of building a company is not that people don't have the skills to do their job, for example, but that people don't know the skills that they do have, whether it's because of continuous positive affirmations, or you just never tried something in an atmosphere where you could get truly honest feedback. If you know exactly what your skill set is, you are invincible. You can make the most efficient use of yourself, your skills, and your time. That is it for my presentation. I know there's some time left. I left a lot of time for questions because I was moving a car out of the snow.
All right, thank you, Danny. So we have a question from Michael. What year was COSAD for you?
That was spring of 2017. And then we did senior design in 2016. So project started fall of 2015, taking ECE 398. I don't think that exists any longer. It's like a pre-445. And then spring of 2016, senior design, and then we went into iVenture the following summer. I got to then TA senior design my senior year, and then COSAD was spring of 2017, which was the same semester I graduated.
All right, we have a question from Mark. Mark has a fairly lengthy question. Mark, if you'd like to unmute and ask it, you can go ahead.
Sure. Can you hear me?
Yes.
Yes.
Yeah. Hi, Danny. Thanks for the talk. I was wondering what component or subsystem in Mesh++ products represents the most exciting or interesting engineering challenge for you?
Oh, that is a great question. I'm going to go with modularity. And for that, I'm going to reprise my showing off my circuit boards over the last couple of years with our current board, which has more modules than the previous boards. Some are connected through M.2 slots. Some you can't see because they're just in the schematics. Some are little PoE modules. In building this product, and in building any product with a lot of different variants, we need to plan for lots of different environments for solar power, and we need to plan for customers needing different bands to communicate on, or different cellular modems or something like that. And it's hard to build a product that can manage all of those. Some of those we managed in purely in the hardware. Like for example, this board can take in USB-C power delivery, power over Ethernet, a solar panel. It can take in a 12-volt adapter, and it can actually aggregate the energy from all of those into charging the batteries, or you can directly power from any of those. So that allows you to have a greater feature set than if you were specifically building a product for one use scenario. But also for the radios, there's 2.4 and 5 gigahertz built in, but there's external radios for 5G and Wi-Fi 6E. And that would have been very, very difficult to do for all of our customers if we were actually putting that on the board. But by having them as M.2 modules, we're able to say, if a customer's in Canada, for example, we have an installation in Ontario coming up. They don't have very much sun there, just like here in Chicago. So we can't just put the highest power components on there. We need to make it as modular as possible in order to just quickly add something on if they need it. In the same way, we can plug in a larger solar panel into this. One thing that we learned with the first revision of our product was that if you build a solar panel into a product, you're not able to quickly replace it if your simulations, for example, on solar power were wrong. And you can also plug this into multiple, you can set voltages for multiple different types of solar panels. On the software side, we have something very similar, where you have a big state machine that figures out exactly what the state that a particular device is in, and then sets up all the various interfaces to be able to do that. That's modularity, to me at least, because it reduces the number of different boards that we'd have to sell. One of the common questions we get is, how many different types of hardware do you need in a particular network? And usually the answer is 2 or 3, at least for wireless. With ours, it's just one. It's just one device that configures itself in different forms. And as a hardware startup, that helps more than anything else, because we just have to maintain a single product which can fill a bunch of buckets through modularity. It's tempting sometimes as an engineer to make everything as small and compact as possible and most cost efficient as possible, which would be, of course, not using a lot of different modules that you have to solder to the board. But it's for a small company especially, it's moving in the wrong direction.
Yeah, thanks so much.
All right. For our next question, we have Alec. Alec, would you like to unmute and ask the question yourself?
Sure. How far away can your devices be from each other before many dead spots start to occur?
So fortunately, because we made our products modular, we have external antennas, and so you can get 5 or 10 kilometers if you have a dish antenna, for example, connected to it. But under normal scenarios where it's an isotropic radiator, you'd have up to 1,100 feet, as long as you have line of sight between all of the points. We're operating at 27 dBm per chain, which is higher than most other things on the market, and kind of just bumping up to the FCC limit. But we are, of course, limited by FCC. I'm looking forward to having the new Wi-Fi 6E band and start getting into phased arrays, for example. I think the lowered interference will allow us to go a lot further. That's a peek into what we're doing next with the company. I will say one of our challenges is that people have started to use our products more and more for indoor use. For example, the Shadowwood trailer park in Champaign, we've covered that area, but people are all using them inside of the homes. And so it's passing through a wall, and therefore you don't have as much range. It's the takeaway being that whenever you're dealing with wireless connectivity and RF in general, there's only so far that you can predict until you actually set it up and see how things are doing. So that flexibility is pretty paramount in a situation like that.
All right, thank you. I actually have a question myself. So when you were designing the product, did you guys experiment with geometries and like what conclusions or like arrangements of the nodes? And what conclusions did you guys like make or find?
That's a good question. We did experiment with geometries, certainly. So in order to assume regular path lengths, we needed some sort of regular tessellation. So that could be like an isometric grid of triangles, for example. That could be hexagons. That could be a 90-degree grid. And the calculations are definitely easier if you just have squares and it's a 90-degree grid. The problem is that you have pretty poor SNR, because if you think of all of those nodes, they're all going to be in a direct row. And so if you're node A and you're trying to talk to node B, you're going to get interference from the next node in the line, node C, and et cetera. And part of that can be solved, and we did solve through time domain multiple access. It's kind of a distributed TDMA protocol. But some of that was inherent to the radios. So we tested out, we ended up with an isometric grid for area coverage, given that we have omnidirectional antennas. So with triangles, we have modified the protocol a bit since then, and our next geometry will be hexagonal. I don't think that's necessarily saying too much, but we were able to simulate that in Python, and there's a few. I'm trying to think of the names of the ones that we used when we were creating this a while ago. There are some tools that allow you to simulate noise interference, signal degradation in ideal conditions over a large area using radios placed at different points in time. And so we used an open source commercially available tool in order to simulate those. Just due to the conditions that we're in, being large area coverage and line of sight, we were able to use more idealized simulation scenarios than we would if we were creating indoor radios, for example.
Awesome. I actually have another question as well. So what sort of technical skills are you looking for in engineers that you hire at Mesh++? And are you currently hiring interns?
Sure, yeah, we'll hire interns. Mechanical skills, so there are a few core ones that present probably the most difficulty in hiring, and I'll mention those first. First is waterproofing. Our devices are IP68 waterproof. That means they're submersible. That is not true for most outdoor electronic products and presents a heating problem, for example. So we simultaneously need something that's submersible and very easily repairable and modular in the field, so that you can insert those radios as you need them, which is a huge challenge. Second is, and I mention this constantly, is modularity, is in designing something that's not fixed. That's a mistake that I personally made the first time in designing the first revision of our products. Next set of skills is a little vague, but it's thinking more outside the box. We have a product that doesn't really exist out in the market, at least in the form that we have it. And so we need to think a little bit differently when we're designing a product. Fortunately, we're able to take a lot more risks than a larger company could. We can accept failure fairly well. So it's easier to take major design risks than it would be somewhere else. But just being able to be more creative and not just saying, these things have been successful in the past, so that I'm going to use them, is one of our more challenging hires. But to summarize, outdoor waterproof electronics is the expertise we're looking for.
All right. We have another question. We have a question from Joseph. Joseph, if you would like to unmute and ask your question yourself.
Sure. So since you have a hardware project, do the cost of various parts and like creating the circuit board ever limit development and testing during the early stages of the product?
I'm sorry, could you ask the last part again?
Yeah. So since it's like a hardware project, did the cost ever limit the like development and testing of the product during the early stages?
During the early stages, yeah. There's only like this, for example, I hand soldered this, and I hand soldered 10 of these, and it took all of my time for like multiple weeks to do all of these because we didn't have the money to have something automated. It's come down quite a bit in price since then. You can automate electronics assembly a lot more easily than you could in the past, both through, well, ECE has the lab, or from China. There are a lot of board houses that'll do that abroad. So I don't know if we'd have the same challenges as we did early on. The biggest killer is the feedback loop is fairly large, especially if you're not, in China next to the board houses. It takes a while from finishing the board to having the fully assembled board that you can test. The time loss was much, much, much more significant than the financial difficulties of prototyping in the beginning. I think that's kind of went away over time, simply because, well, people's salaries are a lot more expensive than board prototyping. Oh, mechanical prototyping. I want to add to that too. It's certainly different in different parts of the world. We're fortunate to be right next to MHub, a hardware incubator that has, hydraulic brakes and all sorts of mechanical tools that we need, power tools, to prototype our parts. Also, 3D printing has come a pretty long way. I know I keep mentioning that we do all this prototyping in China, but it's really enabled a lot of our rapid prototyping. We 3D print in China, and you can get the parts for very, very cheap in 2 to 3 days, usually. So some mechanical prototyping does carry some challenges, some cost. Like, for example, we're making a die-cast aluminum heatsink right now, and we had to CNC the whole thing to prototype it, which is very expensive. But sheet metal, depending on where you go, sheet metal can be prototyped fairly efficiently. You can laser cut things fairly efficiently. You can 3D print things. And all of those together, if you know the right resources and are able to partner with and trust factories, make mechanical prototyping fairly simple as well, although it's certainly not nearly as quick turn, at least, as software.
All right, we have another question from Mark. Mark, would you like to unmute and ask the question yourself?
Sure. I work at a wireless power startup in Chicago, just a couple miles from your office. We specialize in wireless power. Would that be a desired feature for Mesh++ in the future?
No, probably not, unless it was over a very long range. Our devices are pretty far apart, and most of the wireless power, at least most of the wireless power that works efficiently, are like Qi wireless charging that are right next to each other. Of course, I'm making some assumptions there that it's either long range or very efficient, but all of the wireless power solutions that we've looked at have not really been reasonable for powering our devices, which take between 5 and 10 watts. If we do need power, supplemental power with our devices, we generally charge them through power over Ethernet, or even power delivery, or in most cases, just use a larger solar panel.
Okay, thank you.
All right, and with that, are there any more questions? All All right. Seeing none, we can conclude this talk. Once again, Danny, thank you so much for taking the time to come out today and give us a little bit of your journey. Um, with that, I believe we can conclude this meeting. Would you have any last words or last bit of advice for our attendees?
No, just thank you so much for having me. This was a lot of fun. Oh, there's a quick question.
Oh. Michael, you could unmute and say it yourself.
Oh, hello. Okay. Now that you're working in the Democratic Republic of Congo, though, how much possibilities are there for or opportunities for French language workers or interns, especially considering that Champagne has over 5,000 Congolese living here as a refugee community? Would there be opportunities for some of the college students of the Congolese to go back to Congo to work with you?
You know, I did not know that there's that big of a community.
Oh yeah,
Absolutely.
French is our second largest language down here in Champagne. I use it every day.
Huh. I never knew that. Wow. Yeah, there would absolutely be an opportunity. We have to cover a city of 4 million, so there's a lot of work for us to do.
Okay, what's the name of the city? Because
Goma.
Okay, cool. Thanks.
We actually just opened an office in Nairobi in Kenya, officially incorporated. So we don't have an entity in Congo, but we do in Nairobi as of last week.
Oh, okay. So your headquartering, like all your African work, will be based out of Nairobi?
Our permanent employees will be. There would still be some opportunities to go back and make sure that the network is set up well, probably more along the lines of internships than full-time people in DRC.
Okay. Okay. Then what do you have plans then to also go to Malawi? Because like that's Urbana's sister city is in Malawi, and one of the churches here works with a church over there in the town nearby. And a lot of them, like they have flights to Nairobi when they transfer then to go to the rest of the world. And they're English speaking, like Kenya used to be part of the British Commonwealth.
No, we don't
Have you looked at that, or would you want to know more about our Sister Cities program to get leads about that?
Yeah, I absolutely would. That would be great. Thank you.
Okay, because we work with city officials on things over there, so.
Thanks, I appreciate that. We're currently, we have some work in that kind of area of East Africa. As Kenya, Tanzania, and Rwanda are the big three.
Okay, Malawi's right there with them. So.
All right, with that, I believe that was our last question. Once again, thank you so much for coming, taking time out of your day to speak with us, Danny. And I believe that ends this